So in this video, we're going to be going over a general definition of the derivative, and also start introducing what the derivative is. So the derivative of a function f is denoted f prime, and is defined by this function right here. So this function, this is just the limit definition of the derivative. As you go on and learn more about the derivative, there are much simpler ways to find a derivative, but this is just the limit definition, which is a little expanded, but it helps you understand the essence of what the derivative is. And this could help you, especially in calculus 3 and differential calculus. A lot of this is involved, but as you go on, there's going to be an easier way to actually find derivatives. There are derivative laws, but this is just the limit definition of the derivative. So f prime is defined as limit as h approaches 0, f of x plus h minus f of x over h. And this is basically the limit definition of a derivative. And this can be proven by a simple graph. So the derivative is just the slope of a tangent line. And what I mean by that is it's literally just a slope. There are 3 major questions in calculus. The first major question is what is a certain function approaching, and that's the topic of limits. And then the next topic is what is the tangent of that function, and that's the topic of derivatives. And then what is the area of that function, that is the topic of integrals. Those are the 3 major things you're going to find in calculus. So the derivative, so let's say, let me go back into talking about the derivative. So let's say I drew a random function, right? So this is just a random function. Now there's going to be a point. Let me actually make this a little better. So there's going to be 2 points. I'm going to label them, let's see, A and Z. So right here is point A. Right here is point A. Right here is point Z. And I'm going to say that this point A and Z are the domain of this certain function, or a portion of the domain of this certain function. So I'm going to pick 2 points. So we already have point A, we have point Z. Now I'm going to pick output values right here, y values. So this right here I'm going to label as simply as f of A, right? This is similar to basic algebra we learned in like algebra 1, algebra 2. You should know what a slope is, which is just y2 minus y1 over x2 minus x1. That gives you the slope. So that I'm just starting off like that. This is just algebra 1, algebra 2 topics that you should know. So this is f of A right here, and then we also have f of Z. And using the regular definition of a slope, which is y is equal to, slope is equal to y2 minus y1 over x2 minus x1. We apply that to here, right? So m meaning the slope, is equal to y2 minus y1 over x2 minus x1. But in this case, when we're trying to find the tangent, it's going to be denoted f of z minus f of a over z minus a. So this is the slope of this curve right here. This is the slope of this curve right here. And what the derivative basically is the limit of the slope of the tangent line. So this tangent line right here, so when say if I made a line like a line from a f of a, so this is right here, this point right here, it could be written as a f of a, right? This is just normal xy point terms. This is how you just write a regular point on an xy plane. And this right here is z f of z, right? Now say if I made a line from the a f of a to z f of z, this is the line we get, and this is basically the tangent. This is the tangent to this f of x, this curve f of x. So I'm going to label this blue curve f of x, right? And we have 2 points, and there's a tangent intersecting the function. And a tangent, just so you guys have an idea, a tangent is defined as a tangent is basically just a straight line or a plane that touches a curve, basically like a curve at a certain point. And yeah, so it just extends through the function, just like how you see right here. And that's what you just call a tangent. It's extending through 2 points, and it's going through a certain function. So the derivative basically says that this this tangent line can help you approximate values of the slope of a certain curve. So right here, we just got the slope of this curve, but in order to find in order to apply this to the limit definition of finding the slope of a tangent line, we need to apply the property of limits. We need to apply the property of limits. So we need to find the property of limits. So I'm going to move on to the next page, and I'm going to change around some variables. I'm going to copy this graph, but I'm going to change around some variables so it can look something like this. So z minus a. So z minus a. So the limit definition, we know that it's f of x plus h plus f of x plus h minus f of a over h. So we know that we want to get to this form, but we have this right here. So we just set, in order to make them equal to each other, we just set them set them equal to each other. Minus f of a over z minus a. So first things first. So first things first, we're gonna make a minus z So so all right, so first, all right, so I'm just gonna copy this graph into this next page, and we're gonna actually turn this right here into this form in order to try to make sense of the limit definition of the derivative. So we just rewrite the what we did before right here, f of z minus f of a, z minus a. Now you see that a in this this system I just created, the denominators h is equal to z minus a, so we can write this out. H is equal to z minus a. H is equal to z minus a. And the thing about the limit definition is that we want the denominator to actually approach 0. So in order for it to approach 0, that means that z, the difference between z and a, must also approach 0. So when we're rewriting this, we wanna rewrite it like this: limit as h approaches 0. And we know that h is equal to z minus a, so we can just replace z minus a with h to simplify the limit definition. So the next, so we figure out the denominator, which is h. Right now, for the numerator, this is also gonna be a pretty simple algebraic manipulation. So you see, we already know that h is equal to z minus a. All we really have to do is to figure out the numerator and how what function goes into the numerator. We just have to solve for z and plug in what we get for z, but we don't plug in anything for f of a, because f of a is just the starting point. So we don't want to really mess with we don't really want to mess with the starting point of a certain function. So right here, when we solve for z, we get z is equal to h plus a, right? H plus a. So when we're writing it in the numerator, when we plug in z right here, when we plug in for z, we write f of a plus h minus f of a. And this is basically the limit definition of the slope of the tangent line. The slope of the tangent line.